In this video, we will look at the advantages of LED tubes over traditional fluorescent tubes, and we will show you how to rewire a typical fluorescent tube fitting to accept our latest T-Lux series of LED T8 tubes. Let's start by looking at the advantages of LED tubes over fluorescent tubes by comparing the two types. Here you can see an LED tube and a fluorescent tube side by side. The LED tube shown is with our clear diffuser. A frosted diffuser is also available on request. Traditional fluorescent tubes are a mature technology and have been in existence for in excess of 40 years. The technology is old, and today there are many disadvantages in using this older technology. For example, fluorescent tubes contain mercury, a substance that is known to be harmful to humans. LED tubes do not contain mercury. Also, fluorescent tubes produce ultraviolet light. Overexposure to this type of light is known to be harmful. LED tubes do not produce UV light. Fluorescent tubes using magnetic ballasts tend to flicker at a rate of around 100 to 120 Hz. This can cause problems for people with certain medical conditions. Flicker is associated with headaches and eye strain. LED tubes, by comparison, do not flicker. Fluorescent tubes provide a light output around the entire lamp body. This means that a large proportion of the light output is non-directional, with a significant portion of the light it provides being lost within the fitting. The light output of an LED tube is directional. All of the light output faces the surface to be lit. In real terms, it is therefore possible to use an LED tube with a lower lumen output and still provide the same light levels as a fluorescent tube, which on paper has a greater lumen output. Fluorescent tube fittings often buzz and provide an annoying background noise that cannot be stopped without turning the fitting off. LED tubes do not buzz and operate silently. In addition to the benefits of using LED tubes that we've already discussed, there is also the major advantage of their energy efficiency. LED tubes use significantly less power than their fluorescent counterparts and their associated control gear. To illustrate this, a 2-foot 600mm fluorescent tube will consume 18 watts, while the equivalent T-Lux LED T8 series tube will only use 9 watts. A 4-foot 1200mm fluorescent tube will use 36 watts. The LED equivalent will use 18 watts. A 5-foot 1500mm fluorescent tube will use 58 watts compared to just 22 watts for the T-Lux LED tube. Finally, a 6-foot 1800mm fluorescent tube will consume 70 watts against just 32 watts for the equivalent LED tube. As you can see, energy savings can be as much as 55%. Let's look in more detail at our latest generation of LED T8 tubes, the T-Lux series. Our T-Lux range of tubes are designed to fit into any standard T8 light fitting. They are available in the 4 standard lengths mentioned previously, as well as a 900mm 3-foot option, making a choice of 5 standard lengths in total. This T-Lux range provide a highly efficient light output. They can produce up to 140 lumens per watt with a colour rendering index, often referred to as CRI, of 80 to comply with latest building regulations, and are available with a CRI of greater than 90 for special requirements on a made-to-order basis. Our T-Lux LED tubes are constructed from an extruded aluminium frame, and the LEDs are mounted onto an aluminium PCB. This provides excellent heat dissipation for increased reliability and long life. Our tubes are CE, TUV and UL safety approved and have an industry-leading 5-year warranty. We stock tubes in daylight white with a colour temperature of 4000 Kelvin, a natural light that is pleasant to work under and the most popular choice of light colour, as shown here in the middle. LED tubes offering different light output colours such as cool white 6000 Kelvin, shown here with a frosted cover at the top, and warm white at 3000 Kelvin, shown at the bottom, can be supplied on a made-to-order basis. To help you further understand the potential cost savings from using LED tubes, let's take a look at a couple of examples. We will imagine an office building with 50 4-foot fluorescent tube fittings that each contain 4 36-watt tubes that are used for 10 hours per day, 5 days per week, and for 49 weeks per year. You can see from the table that using our T-Lux T8 series tubes instead of fluorescent tubes will result in a saving of around 50%. We will now imagine a larger office building that has 4 floors, each with 50 6-foot fluorescent tube fittings and each containing 2 tubes that are used for 10 hours per day, 5 days per week, and for 49 weeks per year. You can see from the table that using our T-Lux T8 series tubes instead of fluorescent tubes will result in a saving of around 54%. We will now look at rewiring a fluorescent fitting to accept our T-Lux T8 series LED tubes. The fitting we use here is a 5-foot Dextra surface mount fitting for 2 LED tubes, which is widely available. We would recommend that a registered electrician carries out the work to the latest amendment of the applicable wiring regulations. Let's look at this standard fitting and identify the key component parts. We'll remove the diffuser from the fitting to enable the parts to be seen clearly. Here, with the diffuser removed, we can see the mains input connector, T8 tube mounting connectors, ballast, and wiring. There are 2 main types of tube fitting, one with magnetic ballasts and the other with electronic ballasts. You can differentiate between the 2 types quite easily. A fitting with a starter, shown here, has magnetic ballasts, and a fitting without a starter has electronic ballasts. This fitting is a standard 5-foot version designed to take 2 tubes. As you can see from the lack of a starter, this product is fitted with an electronic ballast. On this fitting, the ballast is mounted in the middle. It's worth noting that there are many different types of fittings in the marketplace, and the position of the ballast may vary depending on the manufacturer. Sometimes both the ballast and the wiring are concealed behind a cover, which has to be removed before any work can be undertaken. This fitting is designed for 2 tubes with a single ballast used for both. Fittings designed for a different number or different size of tube may have more than 1 ballast. As mentioned previously, fittings may be arranged in different configurations depending on the manufacturer, but the contents are essentially common. We will now move on to rewiring the fitting for use with our T-Lux LED T8 tubes. To carry out the work, you will require some basic tools. They include wire cutters, wire strippers, screwdrivers, terminal blocks, and cable clips. The terminal blocks may not be required in some fixtures depending on the wiring and existing terminals. Before we start any work, it is important to consider safety, and the first thing you must do is isolate the electrical supply. Secondly, it is important to inspect the fitting to ensure that it is in good condition with no damage to the wiring. The fitting we have here is new and in excellent condition. To modify for our T-Lux T8 series tubes, the fitting needs to be rewired so that live and neutral are present at one end only, as the tubes are single end powered. The next step is to identify the most suitable end for this based on the length and position of the wiring within the fitting. On this fitting, we will select this end, as there are 2 independent wires per tube connector, as opposed to the other end where there is only 1 independent wire per tube connector. We will be disconnecting the ballast that we looked at and discarding this as it's not required for the LED tubes, and if left in circuit, it will consume power and reduce the overall energy saving. Once the wiring for connection has been identified, we will strip out the components that are not required. Let's start with the ballast. Cut all the wires on the ballast and remove it from the fitting. We will now strip out the wiring that is not required. The fitting has been rotated so the next part can be seen more easily. Now we will wire the fitting to accept the tubes. In this fitting, we will need to use 2 terminal blocks as the wiring is not long enough to connect into the existing input terminal. It is important to select a terminal block that is suitably rated for the application. The terminal block that we are using here is rated at 16 amps. To ensure the terminal blocks are installed securely into the fitting, we are using an appropriately sized self-tapping screw. We will use the holes originally used to fix the ballast in place, as these are no longer required. This removes the need to drill holes to secure the terminal block. It is important to note that when wiring the fitting, the wires are routed in the most efficient way and secured in place. Here we are using some cable clips to secure the wires, which we have stripped beforehand. One wire from each tube connector will serve as the live wires, the other 2 will be the neutral wires. We have selected the top wire from each connector as the live wire. These live wires are then both secured into one side of the terminal block that then connects to the mains input live. To complete the process, we will add labels to show what's being done. The first to show that the fitting should be isolated before carrying out any work. The second to show the fitting has been changed for single-end powered LED tubes. The final label to show which end is powered. We now connect the input source. To finish the exercise, we will now insert the tubes. Fit the tube ends into the connectors and rotate by 90 degrees to make the contact between the tubes and the input voltage. Carry out the same operation for the second tube. With both tubes fitted, we can now apply power to light the tubes. This concludes our video. We hope you found it useful.